Number 3 says to use the vertex and the intercepts to sketch the graph of the quadratic function. So this equation is written in the form y minus 1 equals x minus 3 squared. What you would need to do first is to solve it for y. So x minus 3 squared plus 1, when you move the 1 over. Now you have it written in standard form, so the vertex would be the point 3, 1, and then we need to find our x and our y intercepts. Okay, to find the x-intercepts, you're going to set the equation equal to 0. I'm just going to use it in the form we have here. X minus 3 squared plus 1 equals 0. So x minus 3 squared equals negative 1. Take the square root of both sides. X minus 3 equals plus or minus the square root of negative 1. Okay, remember we can't take a square root of a negative, so we have the imaginary number I to represent the square root of negative 1. So when I solve this, I would have x equals 3 plus or minus I. Okay, because these are imaginary roots, this means that we do not have an x-intercept. So this graph will not cross the x-axis. This should say no x-intercepts. Okay, anytime that you get an imaginary root. So we still need to find the y-intercept. To find the y-intercept, we would just evaluate the function at 0. So if I plug in a 0, it's going to give me 0 minus 3 squared plus 1. So negative 3 squared would be 9 plus 1, which is 10. So my y-intercept would be the point 0, 10. So we can use that to graph our parabola. Vertex 3, 1 will always be over 3 and up 1. Then the parabola would cross the y-axis at positive 10. Okay, which direction would my graph be pointing? Okay, is because we have a positive 1 for the leading coefficient. That means it's going to be an upward parabola, and I'm just going to sketch it here on the graph. Okay, the domain for your parabola would always be negative infinity to positive infinity. The range is going to depend on what your vertex is. So for this one, if we were asked for the range, the lowest y value is 1, and then it would go up forever to positive infinity. So we put a bracket on the 1 and the parentheses around infinity. Okay, the next part says the vertex of the parabola in the form ax squared plus bx plus c is found by using the following formula. Okay, this is a formula for an ordered pair. Negative b over 2a is the x value of your vertex, and the function evaluated at negative b over 2a is your y value of your vertex. Okay, remember with any quadratic function you have real numbers a, b, and c, so those are what we're talking about here. We're plugging into the formula. Number 4 is an example where you would need to use this formula to find your vertex. It says graph f of x equals negative x squared minus 6x minus 5. Okay, from this equation, my a value is negative 1, b is negative 6, c is negative 5. So if I wanted to find my vertex, first I'm going to find the x coordinate. So x would equal negative b over 2a. So negative 6 over 2 times negative 1. That's my a value. So I get 6 over negative 2, which is negative 3. Okay, now to find the y-coordinate of the vertex, I'm going to evaluate the function at negative 3. So everywhere I have an x, I'm going to plug in a negative 3. So f at negative 3 would equal negative 9 plus 18 minus 5. So this would be 9 minus 5 would be 4. So my vertex would be negative 3, 4. Okay, then we need to find our x-intercepts and our y-intercepts. Okay, to find our x-intercept, I'm going to use the space I have here. The x-intercept would be taking this equation, setting it equal to 0 to find those roots, or those values. So what I'm going to do is factor out a negative 1, so that I have x squared plus 6x plus 5. Then I can factor this trinomial would be x plus 5 and x plus 1. When I set each root equal to 0, x plus 5 equals 0 would give me x equals negative 5, and x plus 1 equals 0 gives me x equals negative 1. Those are my two x-intercepts. Okay, now to find the y-intercept, that means that you evaluate the function at 0. So if I plug in a 0, negative 0 squared minus 6 times 0 minus 5, this will all zero out, and my y-intercept would just be negative 5. Okay, so I have negative 5 and negative 1 for x-intercepts, and negative 5 for a y-intercept. Okay, plot those now. 0, well, let's start with our vertex. Negative 3, positive 4. X-intercepts at negative 5, negative 1. Y-intercept at negative 5. Okay, I know that this parabola is going to open downward because of the leading coefficient being a negative in my equation. So this would be the graph of your parabola. Okay, you'll have some problems on the homework like 5 and 6 that say determine whether the given quadratic function has a minimum or a maximum value and find the coordinates of that minimum or maximum value. Okay, looking at my equation, if it's a positive 1 coefficient, I know my parabola is going to be open upward. If it's open upward, that vertex is going to be a minimum. So we know I have a minimum here. Let's find what it is. So I can use the formula x equals negative b over 2a. My b value is negative 2. My a value is 1, so I would get 2 over 2, which is 1. And then I would need to substitute 1 in the place of x. So I find f at 1 would be 1 squared minus 2 times 1 minus 6. So 1 minus 2 minus 6 would be negative 7. So my vertex will be 1, negative 7. So this is my minimum point. Okay, my minimum would be negative 7, and it occurs at x equals 1. Okay, then we can do the same thing for the next problem. Because it's a negative, I know that my parabola is going to be down, which means I have a maximum at my vertex. Okay, so I can use the same formula. X equals negative b over 2a. My b value is negative 2. My a value is negative 1. So that's going to give me 2 over negative 2, which is negative 1. Plug in the value negative 1 into the function. So this would be positive 1, but this would make it negative 1 plus 2 plus 1 would be 2. So my vertex would be negative 1, 2. So my maximum would be 2, and it would occur at x is equal to negative 1.